Yes, I'm one of the first-time conference speakers, but I recommend a good way to kind of get into it is find a local meetup and start doing some talks there and get a little comfortable. And so I've done that a few times. But today I'm going to talk about GoKitLog, and Brian, you're going to start using it because you're going to love it. You use Logris now. This is like 2 generations past Logris, and you'll see why I love it because I've got a slide here with some history. So I've been doing Go full-time for about 3 years now, and before that I was really interested in the language. And when I started my first big Go project, I needed logging because it was a distributed application. It's doing stuff on servers where you can't see, and you need good logs to debug things. So I started trying different things, and I wasn't too happy with the various packages I tried. And then, fortuitously, about 2 or 3 months after I started the project, Alan Shreve announced log 15, and I saw that on Gopher, on the Golang nuts, and I was like, that's it, that's what I need. Except it was missing a couple of features. It didn't have the ability to log where in your source code the log statement was, right? Like what file and line number, which is tremendously valuable as a developer to know where that problem happened. So he had filed some issues with help wanted. I need help adding this feature. And I thought, I can do that. So I helped him out, and I added, that was sort of my first, one of my first open source contributions that was of any value. And I started doing that. And then I took that, and after a little while realized that some of the code that I've written to do that might be useful to other people. So we split it out into its own repository in the fall of 2014, go/stack. It's on GitHub. I took all the GitHubs off the front because we were just redundant. Anyway, it's a nice little package. It's very small. It's pretty stable. It hasn't changed in a while. But several different people use it and like it, so that's handy. And then almost a year after I started using log 15, some of you may have been aware of this. Peter Borgon, who's fairly well known in the Go community, did a talk at FOSDEM and said, I think we need sort of a standard library for microservices. I'd like to get people together to start building that. And it received a lot of interest. And I didn't hear about it right away, but about a month after I heard about it, I thought, oh, that's interesting. I may need some of that. So I went and looked at what they'd done, and they had spent a little time basically documenting what we needed in this package, in this set of packages. One of them was a logger, and so I started helping with that because I had some experience working contributing to logging packages. And in order to make that work, we needed to have not just JSON output, but we wanted log funct output, which is something that Heroku kind of started and become kind of popular. And the other packages like Logris and log 15 could do that. So, but they were all just internal code. So I wrote another standalone package just for that around the same time as working on GoKitLog. So I'm going to talk about GoKitLog, but as you can see, I've been kind of working in the Go logging space for a few years now. And this is what I want to talk about today, the GoKitLog package itself, how we designed it, what the API looks like, how you use it. Then towards the end, we'll talk about just some design principles in general that hopefully are useful to everybody that I've learned through this process. And then finally, when you're using logging packages in your code, not necessarily mine, although I hope it's mine, you don't have to, but guidelines on that. So let's go through GoKitLog and how we design it. So before I got involved, several people worked on writing an RST style kind of document. This is what we want. These are the requirements. These are things it shall do, shall not do. These are things it could do if we want or if it works out well. These are the most important ones that they had pulled out. You can see it's going to be, they wanted a structured logger, non-negotiable. They wanted to have the ability to define logging contexts. They wanted to keep severity and log levels kind of separate, but treated the same way you would any other piece of data in logging. And they wanted to be agnostic of format, transport, things like that. So they wanted it to be a very general purpose, structured logging package. And I would summarize that with these 3 points: structured logging, key value pairs across the board, and otherwise try to remain policy free. So that was where things were when I kind of got to it and started looking at what they wanted. And my reaction was, hey, this looks a lot like log 15, which is great. That got me excited because I really like log 15. And I think I can help. And the first question was, do we even need to write a new thing? could we just use an existing package that met all these needs? So we kind of walked through that a little, and it turned out, maybe, but not quite. Like, let's at least try an experiment of doing our own and see if it comes out better than what is available. And Peter's project was really around that, trying to build some best practices. Just because you start down a certain path doesn't mean you have to end it, right? It's all volunteer work, so we were really free. It was like Greenfield, do whatever you want, see what works out. But he had certain principles in mind. And one of those was not to be opinionated about things you shouldn't be opinionated about, but to have opinions, the right opinions. And so that was one of the sort of the little mismatches with Log 15. And the other one was we had some sort of recognized design flaws, things that we learned while working on Log 15 that we thought, hey, that'd be better. We're already on version 2 of the API for that package, and maybe that'd be version 3, but we never quite figured out the right way to resolve those. And so we never quite took that plunge. With GoKit, we had a blank slate. We could go and experiment. So that's what we decided to do. Let's build a new thing. So I dove in. I started writing a new pull request with my sort of idea of what the package should look like. It was just a sketch. It had just a couple of tests, a couple of examples, some interface definition. We were pretty sure we wanted an interface to define the core interaction with logging. And I'd resolved some of my concerns that I got from working with Log, but mostly it looked like Log 15 just simplified. I was pretty happy with it. But then the other contributors took a review at it, and they weren't so happy with it. They're like, well, let's try it. Let's go this other way. So Peter had his own ideas, and he did a separate sort of parallel one after a long discussion on mine, and said, this I think is better. And that was awesome because people were talking about it. And what happened was collaboration, right? We had 3 or 4 people who were really interested in this topic, and they were really good designers. I mean, I felt like I'm just learning all kinds of stuff from these guys. But also I had experience working on other logging packages that I could share with them. Well, if you do that, you're going to have problems doing certain things. And it worked out really well. I mean, the results were better, I think, than any one person coming to the plate having the idea. Really, the final result was an amalgamation of everybody's contributions. It was phenomenal. There was a couple of times we were having this discussion thread, and I remember at one point, someone said, like basically that's it. It was like, and everyone agreed. It was really fun. So these are the 3 core concepts for our logging packages that we came up with. We have a logger interface. We have the idea of contextual loggers, and that's pretty common in other structured logging packages. The one that's maybe a little different is this idea of dynamic context values. And I'll explain all these 3 as we go forward. So let's look at the logger interface. All right, so how many of you have used other Go logging packages and you see, there's like a whole lot of methods, right? And if they have an interface, it's probably like 4 or 5 things. This is our logger interface. This is sort of, right, the one method logger interface. This is the sort of the pinnacle of power in Go interfaces is the one method interface. And when we got to this in our design discussion, we started with like 5 or 6 methods, and then we got down to 2, and then somebody made a comment that triggered a thought, and we're like, oh, we don't need that method in there anymore. It can be a separate function, and we got under 1, and everyone said, touchdown. We knew immediately that this is what we needed. The one method interface is so awesome. So let's look at this. Logger, obvious name, one method, name log, obvious. This key value may not be what you expected. This is a variable list, right? You can have as many different values in there as you want, and empty interface means they can be anything. But there's some rules about it, specifically that we document. That is, it's alternating key value pairs in that list. And this is an idea that we stole from Log 15, actually. I think that was the first package that I saw that did that. And I really liked it. It's very ergonomic when you're using it. A lot of people, when they first see it, they're thinking, oh, I'm going to mess it up. It turns out it's not really that easy to mess up, because when you write the code, you've got a string and value, and a string and your value, and it's really easy to pair them up. And there are rarely any mistakes. So some of the other contributors didn't believe right away, but after discussion and trying it out, they were like, no, actually, this is really good. So we agreed to steal that idea from Log 15. And I think that was a good idea. We see now some other packages, like if you've heard of Uber's Zap logger, which is super fast. And they did a bunch of stuff to make that fast and avoid allocations, but then they realized that they don't always need to be fast, and they added up what they call their sugared logger, and it basically got this same call structure. And another one called Apex Log took this idea as well. So it seems to be a common way now for structured loggers to go to take the arguments. And then the other rule we have is the whole method itself, whenever you implement it, must be safe for concurrent use, because that's just critical to be on a logger. Almost always, all your log data ends up being funneled down to a single output, and you don't want those log calls to get intermixed in an unsafe way. So in Go, you can't really specify that in your interface definition to the language, but in the Go doc, which I've not put here, it clearly makes a contract that all implementations must be safe for concurrent use. So this is how you might use it. You have a method, run task, takes a task in a logger, and I've left out what it actually does, but you can see the log method. So we're starting the task complete, and we're logging the task ID so that we know, what we were doing. And you can see the alternating key value pair structure here. It's pretty easy to understand. If you get a lot of them, you can sort of reorient it so you have each pair on a separate line, and Go formats it nicely, and it's pretty readable. So sometimes you'll see that way, but with this many, it fits all in line nicely. So the output, right? We didn't specify an output format. We're supposed to be format agnostic. Gopher log provides two built-in implementations of logger that actually format the data into common ones. One is log funct, which I mentioned before. I wrote a package for that, and that output would look like this. It's pretty easy to read as a person. It's not too jumbled with a lot of characters, which is why people like it. It's also very easy to parse. There's rules about where the quotes go and when they have to be there and everything. And my log funct package has a parser as well. Though I have to give credit to Keith Rarick, who wrote the first log funct Go parser. That's really fast, and it was quite a task to get mine to be equally fast. But I wanted to have it all in one, so you have an encoder and a decoder in the same package. And then JSON output is also very common, and in this case, there's in the standard library JSON encoder. And as a side note, I'll say though, for this particular task, it's not the fastest, and that's one of the main games that Uber's app has, is they have a custom JSON encoder that makes theirs really fast. I have experimental one that I haven't quite polished up enough, but I'll probably add it at some point that makes ours faster. But anyway, you can see how we can choose the format based on the implementation of logger in this package. I won't talk any more about format for this talk, but I just wanted to share it briefly. All right, so.
Man, you got to be auto-tuner.
Yeah.
Next.
Yeah, that's
Somebody turn off the Daft Punk switch.
cool. Well, let's try this.
Okay, next we're going to talk about contextual loggers, which is the second concept, right? So the purpose of a contextual logger is to store some key value pairs in a logger so that you can repeatedly log them later without having to repeat what you said. This is a very common feature in pretty much all the structured logging packages. Logris, Log15, Apex Log, they all do this. This is how we implement it in GoKitLog. We have two functions, with and with prefix, not unintentionally similar to the context package nomenclature, right? The context package had been published 6 or 8 months before we were working on this. And so we kind of stole that idea of using the word with to say we're having a logger with some more stuff. But we're not using context because the implementation is quite different. And in particular, we can add many key value pairs all in one with statement. But the idea is the same. We take a logger and we decorate it with some new key value pairs, and you get back a logger that has that somehow baked into it. And the difference with and with prefix is with adds them at the end of any already existing context, and with prefix puts them at the beginning. This is how you might use it. Beginning of your function, you have something like the task ID that's relevant to the scope you're working within, right? So you create a contextual logger that has the task ID in it, and then further down, when you log, you don't have to say task ID anymore. It's just going to happen for free. And here we can pass it to another helper function, which doesn't even have the task ID, but anything it logs will still include that because it's a sub-function call of that context, that scope. And the last log statement here, and we get this kind of output. And you can see the contextual logger has helped us be sure that we always have the task ID on every log event that's relevant to that unit of work. And it's always kind of in the same place and formatted the same way. We didn't accidentally typo like ID in different casing the second time we did it because we did it once and it just was that. So contextual loggers help reduce the repetition in your code and they also improve the consistency in your logs. And this was one of the main things that I was looking for in a good logging package because if I was just using a logging package based on like sprintf or something, I found that I was not being consistent. And having any structured logging package that provides this idea of a logging context greatly improved the consistency of my logs, which meant the value of the information I was set. So any package that does this, I say, is better than sprintf style logging. So we wanted to have that feature. And the last concept here is the dynamic context value. So this one's kind of new. There was something sort of similar, but not exactly the same in log 15, but otherwise. And it didn't hold as central of a place as this here. So it was the last thing that we built in the package, the last core concept, because when we started, we didn't even know we needed it. This actually turned out to be a design that came out of trying to keep the package policy-free, which you'll see me say that a few more times later, but still allow it to be extensible to let people do what they want. So let's just, first of all, just say what it is. So it's stored in a contextual logger, a dynamic context value stored in a contextual logger, but it generates a new value every time you log. And that's different than like the task ID where it was always generating the same value, right? A dynamic context value generates a new value. Now, why might you want to do that? Well, we'll get to why in a moment, but let's see how we implement it. So it's implemented with this very unassuming named function type, value. And it's just a function that returns any value, right? This is like, almost says nothing. But it's important because with prefix, you know about this, and they can check for it. And so what they do is when you call the log method on a contextual logger, it'll scan the context looking for values. And when it finds one, it calls that function and replaces it with the value it returned. So that's a very open-ended general purpose tool. So let's see kind of the silly example of how you use it. You can declare a function like this that just counts on some variable. It could be calling a method on a type, or it could be calling a closure like this. And then you convert it to a valuer and put it in your context. And then you log, and you get count 1, count 2. So each time you log, that count goes up by 1, right? Which, I don't know how useful that is, but the reason we wanted it is because when you're logging, there are several types of things that most logging packages kind of bake into the hardcore implementation that turn out can be modeled as a dynamic context value. And specifically, when you're calling, you want to know like where in your code this log event was called from. Well, every time you log, it might be on a different line of code. So that changes. And the other one is timestamps, right? Every time you log, you want to have almost always, you want to have a timestamp of when it happened. And every time you make a new log statement, the time changes. So we, experience from log 15 was it has a big struct that holds these fields, like the caller or the timestamp or whatever, and over time it kept growing. And not everyone needed it. So we liked this idea because we could allow users to decide what goes into their sort of global context and give them a tool to have that, to even include that with line numbers and timestamps without it changing the abstraction. So this is how you might, we also have some global helpers that define some defaults for these things. You can just drop right into that even having to do anything special built into the GoKit logging package. So let's put all this together and look at what a main sort of func program would look like using some of these tools. So first you pick your formatting logger and you just determine the output destination, in this case standard out. And in case you didn't know, standard out in Go is not concurrent safe, so we wrapped it in a little helper here to make it concurrent safe. And then we define our global context with our default timestamp and our default caller helpers so that we'll get line numbers and timestamps on everything we log. And then we start logging. We say, hey, our app started, and we got an error. And this is what the output might look like, right? We have a nice timestamp, long and verbose, but computers love that and it's very precise. And if you go, see, we have one here back here that says you can pick your own format if you want with the timestamp format one if you don't like that long. Then we got the caller information, which is using a stack package I wrote that is shared now with log 15, so it's actually the same implementation of the packages there. And then we have our other log data. So there's one sort of common logging theme that I haven't mentioned at all yet. Does anyone have a guess what I might be thinking of? Levels. Levels. Boom, nailed it. So, right, one of the things that we wanted to avoid was not everyone wants level logging. In fact, over time, I've moved away from it because I think Bill Kennedy's around somewhere and he'll tell you all your logging should be actionable, right? Well, if you have a lot of log statements that you're just filtering out because they're not at the level you want to log at, then is that really actionable? No. So it turns out, I think, over time I've kind of moved away from levels. I just want to log stuff and I decide what's important and it tends that I don't change my level later. So anyway, it's very common that a lot of people do want it. There are applications where it's important. So we do provide it, but as a separate package built completely on top of our core logging package. And that's, I'll just have a couple slides on this. The hard part, this took us a long time to design this level package. We made a first attempt a year and a half ago at GopherCon 2015. Peter and I sat down for a night and hashed through it. There were some issues, but we had something that kind of worked, and we lived with that for a while. But then just recently, in the latest released version of GoKit, myself and Peter and a few other contributors had hashed through what we thought was a better design, and we replaced our old design. And this is how it works. It cooperates much more nicely with the core package. You can have this thing called a level, a filter, where you can specify what levels you want to allow to get to your output. And you just put it into the middle of your level of your logging pipeline there. And then you just need to annotate your log sites with the level that you're logging at. But all of these things take the same core logger interface. It doesn't introduce like a new interface with level methods on there. And that was what we were really, it took us a long time to figure out how to do that right. And then you get this out there, right? We have now a level key value pair, but also the debug one is not there. So there's more features in the level package, but I will skip those for now. You can go look at them on. So some design principles. So I want to shout out to Bill Kennedy in the back of the room. I think it was late last year or earlier this year, he got a tweet about a great article about API design that I hadn't seen before. It's actually about 10 years old, from ACMQ by Michigan. But when I read it, I thought this really resonated. His ideas about API design really, I agree with strongly. And these are some of the highlights I thought from that article. Your interfaces, your API should be minimal without imposing undue inconvenience on the caller, and really should be designing from the perspective of the caller. And that was an overriding theme when we were designing GoKill loggers. We were really trying to think about, from the caller's perspective, how can we make this as easy and obvious as possible. And then the other ones that I really like are these ideas about policy. And this is a belief I've had for a long time. You know, there's packages that have different levels of scopes of sharing. And the more widely shared something is, the more open it should be to customization and modification, because you never know what people are going to want to do with it. So I think these are important principles when designing your APIs, and that was really in the backs of our mind when we were designing our package, but it should be in the back of your mind when you're designing your stuff too. So when you are writing your packages, where should you log? We can use some of those principles to help guide us through that. And one of the things that I think comes out of that thought process is that logging is an application concern. It is not some utility package's concern. Utility packages or any useful package that's going to be used in many applications don't want to log. And the reason is because your logging is a policy, right? You're deciding to output something in a textual format, typically, maybe to standard. Like, who knows if that's what the application really wants you to be doing. And it's generally lossy of information. Like, there's rich event typing information inherent in that log event that maybe the application wants more access to than trying to pull it out of these empty interface key value pairs, right? So shared packages, meanwhile, they should return values. I think we should move towards having more
hooks, callback functions that you call on events internally to let the outside world know what you're doing. And one great example of this in the standard library is the relatively new HTTP trace package, where you can create a context with some special value in it that has a bunch of callback functions that the HTTP client code will call for you, like when it finishes its DNS lookup and things like that. And you can easily translate those into logging or metrics, or you set the table for me great this morning with your talk and how you mentioned, Brian, because I agree with those ideas that you should be able to translate those events into multiple different types of things based on the application, not based on the package that you're writing. So here's my sort of package scope sharing scope spectrum, right? On the left, we have main. On the right, we have our open source, widely shared stuff that people use and you never meet them. And on the left, you can log like crazy, do what you need. That's what your application, it's your concern, you do it. On the right, log at your peril. Don't do that. Give people another way to get access to that data, and they get the log when they use it. And they might turn it into these types of things, like log output metrics, trace events, and distributed tracing, or nothing. Like it may be some really performance important thing, and they don't want to be spending time logging. They want to just do the work. And yeah, they're going to be harder to debug, but if they have performance needs they really need to do, then that's their choice. Or they might come up with something that we never thought of that's really cool to handle those events. Where I work, we have an interesting application that goes out and probes endpoints on things to see if they're still alive. And the author of this tool hooked in with the HTTP trace package to the time, how long did the DNS lookup take, whatever. So he's basically publishing metrics about lookups, and then we run that from all our different data centers so we can see where the network maybe is not performing what we expect. And maybe the authors of the Go tool, if they had just put logging in there, we'd never be able to do that. So these are my last thoughts. Remember, logging is an application concern. Remember that your general purpose packages should be policy free. That's my main message for today. If you don't use my logging package, that's fine. But if you remember to do that, I'll be happy. I'll have made a difference. If you do want to use my logging package, there's the import path. And if you're interested in the bigger project it's a part of, which is GoKit, which is what Peter built as a standard library for microservices, or really we're learning it's useful for sort of what we call the elegant monolith as well. There's a website with all kinds of great facts and Q&A and links to the GitHub. We have really great contributors on that project. I learned a lot from them. And that was the main reason I got involved, learning about microservices, and luckily I was able to help the logging package be good. So that's it. There's me on Twitter. I'm on Gopher.